Welcome to the second half of section 8.3. In this video, we're talking about reference angles, and we are discussing how to determine the sign of a trig function for a reference angle. So first, you should have your note-taking with vocabulary in front of you. We're going to read the reference angle relationships. Let theta be an angle in standard position. So remember, again, standard position just means that the initial side is on the x-axis, and maybe the angle is going to, maybe it's like this. So maybe that's 150 degrees for an example. Okay, so that's an example of an angle in standard position because its initial side is on the x-axis over here. So let theta be an angle in standard position. The reference angle for theta is the acute angle, theta prime, formed by the terminal side of theta and the x-axis. So you need to underline that sentence. The reference angle for theta is the acute angle, theta prime, formed by the terminal side of theta and the x-axis. Okay, so what does that mean? So looking at my example, I drew a 150 degree angle. It's in standard position. This is the terminal side, okay? My reference angle is the angle that's formed between the terminal side and the x-axis, the smallest angle that I can create with the x-axis using the terminal side. So my theta prime, my reference angle, would be this part. And that angle, how would I get that? Well, my original was 150 degrees, so my reference angle, and I just call it, they call it theta prime, I just label it RA for reference angle. I find that by doing 180 minus my original angle. So 180 minus 150, so my reference angle is going to be 30 degrees. So it would be this angle right here. Okay, the relationship between theta and theta prime, or the original and the reference angle, is shown below for non-quadrantal angles. Okay, I'm not even going to read that. Just let's look at the picture. So if your original angle, if the terminal side is in quadrant 2, then your reference angle will be over here, and you'll just find it by saying 180 minus whatever the original angle was. If your angle is in quadrant 3, like this one, then it's still the distance between your terminal side and the x-axis. But in this case, you're going to, I feel like it gets kind of technical here to explaining how to find it. It's just, you have to find the difference between your terminal side and the x-axis using 180 degrees. Sometimes you have to add, sometimes you have to subtract. So in this situation, to find your reference angle, you want to do the original angle and then subtract 180 to figure out this part here. And then if you're over here in quadrant 4, then you could say 360 minus whatever you got for the original angle, because that's going to be the closest route back to the x-axis. So the reference angle here is just going to be the distance from the x-axis to the terminal side. And if you're in quadrant 4, just do 360 minus the original angle measure. Okay, so we're going to practice with reference angles before we go any further. So if you flip back over, let's look at example 5 on your extra practice. So example 5, we're asked to sketch the angle negative 310 degrees. Okay, so remember, negative means you go counterclockwise. No, I'm sorry, negative means you go clockwise. Okay, normally you would go counterclockwise. So I'm going to start over here. I want to draw 310 degrees. All right, so this is going to be negative 90, negative 270. I'm sorry, that's not right. Do it again. We'll start here. Negative 90, negative 180, negative 270, and then a little ways further in here. So from 270 to 310, that would be another 40. So there's my angle. And that would be, so how do I get my, so that's negative 310. How do I get my reference angle? Well, it's going to be the distance from here to 360. So if you, the full rotation is 360. If we do 360 minus 310, or we could think about a coterminal. It might make more sense to think about your, what's another way, what's a positive coterminal angle for negative 310? If I had gone this route, what would it have been? 360 minus 310 is 50 degrees. Okay, so my coterminal angle is 50 degrees. And because that is in quadrant 1, it's also my reference angle. So my reference, so again, this was the terminal side of the original angle. I needed the angle measure between the terminal side and the x-axis, and that was the 50 degrees. So my reference angle is 50 degrees. Okay. In number 6, you've got one that's given to you in radians. So in this situation, you can work with it in radians, or if you prefer to work in degrees, you can always convert it to degrees. I know that 27/10 is close to 3, and I know that 3 pi, I know 2 pi is a full rotation, so there's 2 pi. 3 pi would be back over here on this side again. But I'm not quite that far. I'm close to it. I'm 2.7, 27/10. So it'll be about like this. Okay? The reference angle is the angle between my terminal side and the x-axis. I've got to figure out what is the angle from here to here. And how can I do that? Well, this is 27/10, or 2.7. So how far is it from 27/10 to 3? All the way down to the x-axis would have been 3 pi rotations. So that would be 30/10. So from 27/10 to 30/10, that would have been 3 pi over 10. So that would be 3 pi over 10. If you don't want to do it that way, you can, what if we converted it to radians first? Or excuse me, what if we converted that to degrees? Okay, so I don't know if this is showing up very well. I'm going to zoom in a little. If I converted this to degrees first, and I'll grab another sheet of paper. So I'm going to go back and just sketch in what I had in number 5. I don't know if it's showing up. My original angle was this, the negative 310. And then the reference angle was 50 degrees. And then in number 3, I had sketched in, I had started here, and I had gone 90, 180, 270, 360, oh, excuse me, I was doing radians, but at any rate, I was over here. So that was my 27 pi over 10, and my reference angle was over here at 3 pi over 10. So now I'm going to say, what if I had done it using degrees instead of radians? So some people, if you're not comfortable working with numbers like that, if you wanted to convert 27 pi over 10 to radian, see if I, excuse me, if I wanted to convert to degrees, so I could first convert to degrees. I could do that if I multiply by 180 over pi. So then this would give me 27 times 18. And 27 times 18 is 486 degrees. Okay, and I have to find the reference angle for 486 degrees. Okay, well, I think it would be easier if I did a coterminal angle. So, because I know 486 is more than one complete rotation. because a complete rotation is 360. And then I keep going. How much further to 486? If I do 486 minus 360, it's the same as 126 degrees. So that's another 90. And then 126 is going to put me in here, up here in quadrant 2. So there's a 486 degrees. All right, how can I get, in order to get my reference angle back here, I'm going to use 126 instead of 486 because it's the same thing. So if I do 126 degrees as the coterminal, I could just say 180 minus 126, and that would give me the gap here. So 180 minus 126 gives me 54 degrees. So my reference angle is 54 degrees, which is good, but they want me to express that in radians. So to get that into radians, I'm going to say 54 degrees times pi over 180 and multiply those. So that's 54 pi over 180, and if I can simplify 54 over 180, what can I do? If I divide them both by 2, I've got 27 pi over 90, but I can reduce that as well. Divide that by 3, and I've got 9 pi over 30. I can reduce that too. Divide by 3 again, 3 pi over 10. And there we go, that's our answer. Okay, so 3 pi over 10 for my reference angle. Okay, so number 6 was 3 pi over 10. Okay, and before we do number 7, I need to try to help you organize all this. Let's go back to the previous page in the notes. Okay, and they've got guidelines for how to evaluate trig functions. Okay, so it says, use these steps to evaluate a trigonometric function for any angle theta. Step 1, find your reference angle theta prime. Step 2, evaluate the trigonometric function for theta prime. Step 3, determine the sign of the trigonometric function value from the quadrant in which theta lies. So, for the most part, finding, say, sine of 274, or let's say sine of 280, it's the same thing as finding the sine of the reference angle. So the reference angles are super important. They're very helpful. Once you know what your reference angle is, like we did up here, once you have a reference angle like you did up here, you can evaluate the trig function for that reference angle without having to use these big numbers. But you have to be very careful about the sign that your final answer is going to be, whether it's going to be positive or negative. So, to help you keep all this straight, there's this little mnemonic device called, I call it all silver tea cups. Okay? So what this is saying is I've got an ASTC. If my original angle, or if my reference angle falls in, if my original angle theta falls in quadrant 1, then all of the trig functions will be positive. And that's what they're saying, telling you right up here. If you're in quadrant 1, sine, cosine, tangent, cosecant, secant, cotangent, they're all positive. So you can just put a big A. Everything's positive if your original angle, if the terminal side of your angle is in quadrant 1. If you're in quadrant 2, look at your notes. Sine and cosecant are positive, but the others are negative. So I'm just going to say that sine is positive. So I'm going to put an S here. So quadrant 2, I put a big S. That's all silver. Now, I know that cosecant is the reciprocal of the sine function. So whatever, if sine's positive, cosecant's the same. If sine's negative, cosecant's the same. All right, so I've got all silver. If I'm in quadrant 3, tangent is positive. So we'll put T down here. So if my original angle has a terminal side that lands in quadrant 3, then the tan function for that angle will be positive. And its reciprocal cotangent is also positive, but everything else will be negative. And then finally, if the terminal side of my original angle lands in quadrant 4, cosine is positive. So I'm going to put a C. And because secant is the reciprocal of cosine, it will also be positive, but everything else will be negative. So I've got all silver T cups. So quadrant 1, all the functions are always positive. If my angle is in quadrant 2, sine is positive. If my angle is in quadrant 3, tangent is positive. And if my angle is in quadrant 4, cosine is positive. Okay, so that's what I mean by all silver teacups. So let's look at one. They give us one example to practice. I'm going to do more than one with you. I'll choose one from the homework to do with you as well. So in number 7, you're going to probably need a little bit more space than you're given here. So for number 7, evaluate the function cosecant of 150 degrees without using a calculator. Oh, and we're going to need one other piece of information as well. You're going to need this thing. At some point in your life, if you continue and take trigonometry or higher in college, you will have to find a way to memorize these values. I'm not going to make you do it right now. And there are tricks to help you figure these things out. But for the time being, I'm just going to give you this sheet to use as a reference, and you can use this on your test. This is trigonometric values for special angles. So if you're asked to calculate sine of 60, then you can just go on here and see it's square root 3 over 2. If you're asked to find tan of 30, you can just go on here and see it's square root 3 over 3. I don't even use this side of it at all because these are the reciprocals of the original 3. I just use the first 3. And I have a hard time memorizing, so I'm going to let you use this as a reference. So if you are asked to find sine of 45 without using a calculator, this is how you would do it. You just read it off of here and it will be square root 2 over 2. Alright, so now we're ready to do number 7. Evaluate the function cosecant of 150 degrees without using a calculator. So cosecant of 150 degrees. So the first thing I need to do is find the reference angle. To find my reference angle, let's draw a picture. Think about where it is. Here's my initial side. That's 90 degrees. 150 is not quite to 180, so we're going to stop in here. And we can see that the terminal side lands in quadrant 2, so that's important. But the reference angle is going to be 180 minus 150. So the reference angle is 30 degrees. So my reference angle is 30 degrees. That's step 1. Okay, step 2. I need to decide if this answer will be a positive or a negative. Because my initial side is in quadrant 2, I know that only the sine function is positive in quadrant 2. What's the reciprocal of the sine function? Well, the reciprocal of sine is cosecant, which is what we have. So since cosecant is the reciprocal of sine, it's also going to be positive. Okay, I feel like it's a lot to keep straight, and it is a lot to keep straight. But because so we know, let's just write it this way. Cosecant is 1 over sine of 150 degrees, okay? So that's cosecant of 150 is 1 over sine of 150. And we know that sine will give us a positive answer when it's in quadrant 2. So we have 1 over And now we can put in our reference angle. So we'll say sine of 30. So 1 over sine of 30 degrees. And we got to find what is sine of 30. We're going to say 1 over. And then sine of 30, if I look on my sheet, I see that sine of 30 is 1/2. So I'll put that in for sine 30. It's 1/2. 1 divided by 1/2 gives me an answer of 2. And it's positive because it was in quadrant 2. The sine function is positive in quadrant 2. So number 7, the answer was 2. And I will scan this and include it with your notes. Okay, I'd like to do another example with you. One of the ones in the homework. Okay, this is actually not in the homework, it's from the textbook, some examples from the textbook. Let's find, okay, maybe it is one from the homework. Let's do cosecant of negative 420 degrees. Alright, cosecant of negative 420 degrees. Okay, so to find cosecant of negative 420 degrees, first thing I need to do is find my reference angle. So if I draw a picture. Alright, negative 420. It's a negative angle, so I'm going to be going clockwise, starting over here. So that's one rotation is 360. And then how much further? If I go 360 plus another 90, okay, if I were to go all the way back, all the way down here, that would be 450. So I need to back up and not go quite that far. So negative 420 is going to be in quadrant 4. And I have to find the distance from here to here. So my reference angle, alright, so if I had gone all the way down here, that would have been negative 450. Subtract 30, that gets me here. So if it's 30 degrees from the y-axis to this terminal side, that means that it's got to be 60 degrees from here to here. So my reference angle is 60 degrees. Okay, now if my reference angle is 60 degrees, and let's see. Okay, so we found our reference angle is 60 degrees. So the next step is to decide if our answer is going to be positive or negative based on the location of the terminal side. So since the terminal side is in quadrant 4, remember all silver tea cups. Okay, so since quadrant 4 has a C, that means cosine and its reciprocal cosecant will be positive. And we have cosecant, so our answer will be positive. So we can write, cosecant of negative 420, we can say that's cosecant of negative 420 equals 1 over sine of negative 420, because that's what the definition of cosecant means. And then we can replace sine of negative 420 with the reference angle. So 1 over sine of 60. And we already decided that this is a positive answer, so we don't have to worry about putting a negative in front. Alright, so we've got 1 over sine 60. Alright, well, what is sine 60? And go on your sheet. So it's only going to be the 30 degrees, 45 degrees, and 60 degrees angles that you're going to be using this sheet for. Sine of 60 is square root 3 over 2. So we'll make that substitution. Square root 3 over 2. okay? But we need to simplify that. So this is 1 times the reciprocal, 2 over square root 3. So 2 over square root 3, and then we have to rationalize it. So square root 3 over square root 3, that's 2 square root 3 over 3. And again, it's positive because because cosecant is positive in quadrant 4. Okay, so that's the way these examples are going to work. I think you've seen enough to be able to do it. Let me know if you need some help. But your assignment for the second half of section 8.3 is, I'm going to find my paper. Okay. Okay, so this one, that answer was 2. 8.3 part 2. The homework is page 430, 15 through 21 odd, 25 through 32 all, and number 41. Okay, so this will be in Schoology as well. And that's it for section 8.3.